What is MLOps? MLOps is modeled on the existing discipline of DevOps, which is the modern practice of efficiently writing, deploying, and running enterprise applications. So what does that mean? Way back in the day, when people were just coding on their own, they could get away with just doing things in a very disorganized way. But if you've ever worked on a team of more than one person, you know that there needs to be a plan. There needs to be an organization of who does what. And that's where the practice of DevOps came into play. There's a cycle, there's a plan, everybody knows their role. And so that same principle was applied to machine learning to create MLOps. And why do we use MLOps? We use it so that there aren't any riots like this with developers taking their swords and fighting against each other. It just clears up any confusion and makes it so that there are no bloody fights later on. So here is the process. Step one is you get your data set. You build your data set and you label it. Step two is data cleaning. You clean and curate your data set. Then model selection. You can use your own experience. You can find a model on GitHub, or you can go to archive.org. And you also tune the model once you've selected it. Then you deploy it, which just means make the model accessible to people within your company or publicly. And then the last part is babysitting, because once you've made it accessible, you still have to do some work because models lose effectiveness over time. So you have to keep babysitting it, and your job is never done. All right, so step 0 is one that I made up. It's not in the MLOps pipeline or in the MLOps process, but I think it is the actual most important step. You have to know your goal, and you have to write it down. You have to be very, very specific about it. I read a statistic recently that 87% of machine learning projects in businesses fail. And I think it's largely because of this. I think a lot of customers say, oh, we want to use AI, we want to use machine learning, and they never really define a goal. So you need to clarify with your customer, when is the project due? And if we're trying to predict something, if we're trying to predict sales or any other number, how far in advance do you want it predicted? What kind of accuracy do you need? What is your goal for machine learning, and why are we using machine learning? And then finally, who do I talk to if I have questions about the data or about the business? So Sun Tzu, in his book, The Art of War, written around 471 BC, said, know yourself and know your enemy, and you need not fear the result of 1,000 battles. A lesser known treatise that he wrote the next year was The Art of Data Science. And he said, know your goal and know your data, and you need not use the hottest new model on archive.org. Some people say he was ahead of his time. So, in summary, a great new model plus bad data plus no understanding of that data will give you bad results no matter what. An old or simple model plus great data plus a thorough understanding of that data will give you great results. And you don't have to use an older and simple model. You can use the state of the art. But what I'm saying is there's a big contrast between knowing what you're doing with the data and not knowing. So the first step is data set. First part is collection. So let's say we're trying to train an AI to recognize what a picture of a cat is. We will collect thousands of cat pictures online. You could just do a Google search and download every cat picture you see. Ingestion is for if you are working on kind of an active model training. For instance, for a credit card company, they are always receiving credit card applications, and they might want to train their model every single night. So how do they get that data from the database where it's kept into a place where the model can use it? And that's what ingestion is, and that's how we build a pipeline. And there are entire books on this. There are people whose entire job is building a pipeline. It's a pretty complicated thing. Then there's labeling data, as in when we download those thousands of cat pictures, we have to label each one cat, 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 because it's a type of machine learning called supervised learning, where you show the machine an image and then you tell it what that thing is. We can also use data versioning, just like you use Git to version your code. You can have different versions of your data set. Like you can say, this is version 1.0. And then version 2.0, we deleted all of the dogs. Version 3.0, we deleted any yellow cats. And then later on, you find out that it actually worked better with the dogs in there for some reason. And so you have these different data set versions, so you can just go back and forth very easily. Also, as I mentioned before, it is incredibly important to understand your data. You have to know where it came from, how it was generated, and know the industry and the business, and make as many phone calls and emails as necessary to understand it completely. I thought that this was just like one of those things that teachers tell you, but it isn't real. But oh my gosh, when I actually got a job in the field, it was so important because we received 3 types of data and nobody knew what the 3rd type of data was. My boss didn't know. His boss didn't know. I had to call so many people to try and figure out what this data was. And we didn't know if we were making any progress. Again, this is not at Facebook. This is a different place. Okay. All right. So data cleaning is the process of picking the data that you want to use and analyzing and visualizing it. Like you can just plot it in Matplotlib or whatever you want. Then you inspect it. You validate the data and make sure that you can actually use a machine learning algorithm on it. And you reserve some data for testing later. The model search is where you pick your model. You have to prepare the data for insertion into a model. You choose a metric like accuracy or precision, and you try different models. A lot of times you can find a good model on GitHub. For my last position, what we did is we looked on archive.org and we found like 5 or 6 papers of research where people had done something similar. And so we used those to create our own model. So we can validate the model on training data to make sure that our model is actually working the way that we want it to, and it's giving us the results we need it to. And just like your code or your data set, you can track model versions and metrics, as in this model with these parameters scored 98% accuracy, this one scored 92%. So deploying is just hosting the model. So you could just host the model by itself, the trained model as a file. You could host that online. Or you could host an API endpoint where people would connect to the endpoint, upload their data, the data would go through the machine learning experiment, and then give them results back. Or another thing that you can do is every time the API gets called, a Docker container opens and runs whatever input the user sends through the model, and then it returns the results. That's how it's often done because it scales really well. And you can also test your results using your deploy. All right, so as we talked about babysitting, you need to monitor the model performance. If it's not doing well, if people are complaining, then you need to go back and maybe retrain the model on some newer data. You need to update it because models slip. There is a guy named Denny Briz, and he claims to have figured out the stock market using artificial intelligence, using reinforcement learning specifically. He claims that he made many times his normal salary by playing the stock market, but it only worked for 2 years. After 2 years, the exact same program stopped working. So that's just an illustration of how you need to update your models regularly. So I'm going to show you a really quick demo because I don't have much time left. I'm going to upload data, train a model, and then save the model. So I had done tutorials on this before, and I didn't actually believe this was how people do it, but this is how big businesses do it. So if you're familiar with Amazon Web Services, you access their services by just clicking up here and searching for something. So S3 is their scalable storage. All I have to do is upload my data. I click here, and then I upload a .csv file. Then I get the path for the CSV file from right here, URI, Universal Resource Index, I think. Then I have a Jupyter notebook running. SageMaker is just a computer that you rent from Amazon, and it has a notebook attached. So then I just install these packages. This is the address for that CSV file that I uploaded. Then I pull it into pandas. Then I run a machine learning experiment. I just use linear regression. I train a model, and then I pickle that model, right? And then I send that model out back to my S3 bucket. I can use that same S3 bucket, and then it will store it. Let me see. Yeah. And I can store my model in that same S3 bucket. But I probably would not want to store them in the exact same bucket. I would want to have 2 folders, one data and one would be the model. And then so once I have the model stored here, I would create a Docker container that once it starts up, it pulls that model and then takes whatever data the user entered, runs inference on it, and sends back the results. And then Amazon can scale that up infinitely. I can just give AWS this one single Docker container, and they can scale it up. So every time somebody tries to connect to this machine learning program, it creates a new Docker container, and it can scale up infinitely. Paul Starrett, I have heard of synthetic data. Synthetic data is awesome. It's really cool. I think it's the future. And I think I'm out of time. So I appreciate you guys bearing with me. I know I said a lot of stuff fast. I'm happy to answer questions afterward. I will be sitting at one of the tables. And that's it. Thank you.